Okay, we're in section 7 of the notes, and we're going to do the problem set now, the examples. This is where we're going to reinforce what was presented in lecture, and we're hoping you can follow what's given to you. Certainly the problems I start off, I'm not going to say, terribly easy, but fairly easy, and they may get more difficult over time. But the bottom line is, after the lecture, we're going to go through a set of examples that you need to pay attention to, and then you need to try on your own at some point, all right? Let me switch to the whiteboard, and we'll go through the example one by one. And give me a second to get my whiteboard on. All right, so let's take a look. And this one, they want me to use integration by parts. That's what this section's about over here. And they're telling me what the parts are. And let's write this down. So I know my integration. My integration is going to be x cosine x dx. And what do they tell me? They say use u for x. That means du is equal to dx. And then they go on to say that dv is equal to cosine x dx. Now, of course, this could get difficult, but the bottom line is, do I know the antiderivative of cosine? I do. It's sine. The constant of integration is going to be added on at the end of the problem. I'm not going to do that now. So then looking at this thing, what do I notice over here? This is the u, and this is the dv. So what do I need to write down? I need to write down uv minus v du. Let's see if we can do that. What's uv? Well, uv is simply just x times sine of x minus the integration. Well, what's v? V is sine x, right? And what's du? It's just dx. All right. Now, by the way, I still have an integration to do. My hope is the integration's gotten easier, and it certainly has. So let's continue to write this down. We'll look at the key later. It's going to be x sine x. Now let's see, what differentiates the sine would be minus cosine. So it's going to be plus cosine of x. All right, plus c. All right. So what I'd recommend you do now is you look at the K, see how we did. Mistakes happen. Everyone makes mistakes. So what's the key say? X sine x plus cosine x plus c. Not bad. Let's go to the next one. And again, they're telling me what to do. Now, someone says, I don't like to be told what to do. Well, we're learning, right? So let's write this down. We want to do the integration. Natural log of x dx. And what do they tell me? They tell me u is the natural log of x. That means du is equal to 1 over x dx. Well, it looks strange, doesn't it? And then what do you get over here? Then they tell me that dv equals dx. Well, I got to do the antiderivative, and that's going to be that. Constant integration can be added on the end. So let's write this down. And I'm looking at it, and I'm going to say this is the u, and this is the dv. So what do I need to write down? Let me remind you. So I'm going to write down uv minus v du. See if we can do that. What's uv? X ln x. All right, I got that down. Minus what goes here? What's the v? It's x. Times what's the du? It's 1 over x dx. I get to keep moving forward. What does this give me? X ln x minus an integration, provided x isn't 0. What do you get? 1 dx. Well, this is much easier integration to do now. So what do I get over here? X ln x minus the antiderivative of 1, which is x plus c. My answer. Let's look at the k. And again, I can't encourage enough. Look at the key. We give it to you for a reason. We want you to look at it. So what are you going to the x ln x minus x plus c? All right, let's go to the next one. All right, I'll take a look at this one over here. Again, I'm still in the mode of them telling me what to do. You can certainly say, I don't want to be told what to do. I just want to try something. And that's the goal. We want to get you to try something. So what do you have here? We'll write this down for you. You get x to the 6th power times the natural log of x dx. So what do you get? They say use u to be the natural log of x. What does that mean? Du would equal 1 over x dx. And then they say dv, I'll write this down for you. They're telling me is x to the 6 dx. What am I going to write down? The antiderivative now, without the constant, of course. I'm going to put that in later. And what would that be? Well, that would be x to the 7th over 7. Let me write this down for you. And again, I'm trying to remember what to do. So it's going to be uv. So it's going to be x to the 7th ln x. I'm doing uv over 7 minus v, the integral, I'm sorry, integral v x7 over 7 times du, which is 1 over x dx. All right, let's keep moving. And I'm hoping things are going to get easier. If they don't get easier, I'm going in the wrong direction. But when I say that, if they don't get easier, stay the same, we're going in the direction, bad direction. So it's going to be x7 ln x over 7 minus 1/7. That's not so bad. Whoops. Integration. And that would be x to the 6, right? Well, I think I can do that. And I'm going to remove that integration symbol now. So it's x7 ln x over 7 minus 1/7. The antiderivative of x to the 6 is going to be x7 over 7 plus c. Again, once I move all the integration symbols, I'm going to put c down. Let's write the answer down. x7 ln x over 7 minus x7 over 49. All right, plus c. If you want, you can rewrite that. A lot of times you're going to be confused by the answer keys. Let's take a look, see how we've done. All right, I'm looking at this over here, and I'm seeing it. I think I'm seeing it anyway. Let me make sure I'm seeing that. x7 ln x7. Yep, bingo, you got it. It's not bad. All right, let's do this one over here. And again, they're telling me what to do. And again, at some point that has to stop, right? So let's put this down for you. So you get x squared times sine 4x dx. Well, they said use u to be x squared. That means du is equal to 2x dx. And then they say dv, I'll write this down for you, is equal sine 4x dx. Well, we have to integrate. So it's v. Well, that would be minus cosine 4x over 4. And there would be a constant, but we're going to do that once we remove all the symbols of integration. So I have to write this down now. That's going to be uv. So that's minus x squared cosine 4x over 4. That's uv minus v du. So that's minus and minus, so plus cosine 4x over 4, 2x dx. I'll write that down for you. All right, by the way, the integrations got easier. So for example, the first integration had a square in it. Now this next integration does not have a square in it, but I have to struggle now because I don't recognize it. So I'm going to write this down. So it's minus x squared cosine 4x over 4. Let's keep writing this down. So that's going to be plus 1/2 an integration x cosine 4x dx. And again, I don't recognize it. So the thing about now is that I have to do another integration by parts. Right? This can happen. Do it more than once. So what I'm going to do over here, I'm going to cross this one out. I'm done with that. I'm going to do a new one now. So let's take a look as we can do it. So I'm going to say, just, a guessing game over here for the most part. Not really. U is equal to x. Du is equal to dx. Now, if I said u is equal to x, that forces me to say dv is equal to cosine 4x dx. And I got to do an integration now. And again, it should be easy, right? So it's going to be sine of 4x over 4. Again, we have a key to look at later. All right, so let's write this down. So it's minus x squared cosine 4x over 4. Let's keep writing it down. Whoops. Plus 1/2. All right, it's problem. I have to put down uv, right? So it's going to be x sine 4x over 4. We'll take care of that later. Minus, let me put this down. It's going to be, let's see. I did uv. Rather than put out what we're doing, now we're going to put down the du, which is dx. And the v, which is sine 4x over 4. And yeah, for a lot of students, this is like, it's so much writing. When is it going to be over? Well, I'm going to keep, writing it over and over again. So minus x squared cosine 4x over 4 plus, that's going to be an eighth, right? So it's going to be x sine 4x. So I'll make a mistake here. It's going to be minus 1/8 now, right? Sine 4x dx. Now, by the way, the integrations are getting easier each iteration I go through this with. Friends, it may not be over yet. Let's put this down. Minus x squared cosine 4x over 4 plus x sine 4x over 8. And let's see if we can put this last integration down. So minus, well, not minus, right? Because I have to get a cosine, right? So it's going to be plus, I think I'm getting better at this, right? So cosine of 4x, and then it'd be 4 times 8, which is 32 plus c. Again, we're going to put the c down once I remove all the integrations. All right, this definitely got more difficult, right? But I'm glad they started me. So what I want to do is I want to go back to the key, and I'm going to point out what I'm doing over here. I don't know, maybe I got it wrong. Oh, you know what? It's not even on this page. It's on the next page. I'm going to copy it. Forgive me for doing this. I'm going to paste it over here. And let's see how we did. And this is what we're trying to teach you. Check your work. How do you check your work against a good key? So I think I got the first term. I got the second term. I got the third term. And I got the constant of integration. Things are going away really nicely. Let's go to the next page. And let's try number 5 now. Now, I want to point out that, again, they're writing something down for me to read. So they say, use u equals cosine of x d. Then they say also rewrite. So I'm going to do it both ways, right? And someone says, do I need to do it both ways? Well, it's not me needing to do it both ways. It's you that needs to do it both ways. You need to practice, all right? Not me. All right, let's say the first thing, and I'm going to do this first guy over here and see if I can do it. And I'll write this one down for you. And I'll write down a little differently. I'll write down cosine x times cosine x dx. And I'm going to use the integration by parts. They say u is cosine x, and they say dv is cosine x dx. So I'll try this first. Looks pretty easy. What's du minus sine x dx? What's v? That would be sine x. Again, the constant integration is coming last. Let's write this down. It's going to be uv. Well, that's pretty simple. It's just cosine x times sine x minus v, which is sine x, times du. Whoa, this gets more difficult, doesn't it? So it's going to times another sine, right? So it's going to be sine squared. All right. So someone can say, this is really, did it get better? Not really. It didn't get better. It stayed about the same in difficulty. So what I want to do is I'm going to cross this out. I'm going to try again. right? Let's write this over here. U is sine x, du is going to be cosine x dx, dv would equal sine x dx, v would equal, let's see, minus cosine, right? Right. Let's keep going. I know it's difficult. We want to encourage you to move forward though. uv, what's that going to be? That's going to be, what's that going to be? Did I do that right? Cosine x sine x. Make sure I did something over here. Minus sine, yep, dx, dv, cosine x. Yeah, I did it right there. And then let me see if I did this right. Yeah, I did it right. Sine x, cosine x. Yeah, I guess I have to get my eraser out now. Not that there's a mistake here. I just want to erase this over here. So I got my cosine x, sine x, and now I'm going to put down minus sine x, cosine x. And then what do we get now? Minus, I just did the uv, now v du. So it's going to be plus cosine x. And then dv, which would be, I'm sorry, du, which would be cosine x dx. Wow, it looks like I'm in an infinite loop, an absolute infinite loop. And that's probably not such a good thing to be in. You know what? I think I made a mistake somewhere because I'm looking at my key. And let me see where I made a mistake. And this could happen. I write the problem down correctly? Yeah, cosine squared, cosine sine. Did I use the correct substitution? U is cosine x and dv is cosine x. The integration would be sine. I did that. Cosine sine. And I got sine squared. I did sine. Derivative of sine is cosine x dx. dv. uv. Yeah, this is problematic because it's just going to keep feeding back on itself. So I have to rethink. All right, so we hit a dead end. So when you hit a dead end, all I can say is back out. I'm going to back out now. It's a dead end. And the reason I'm getting something, I'm getting just the original integration back. And that's not helpful. It's just not helpful to get the original one back. I'm back at square one. So because these disappear, by the way, and I'm left off with the same integration, well, it's a dead end. So I got to rethink about it. All right. So one thing I think about is it certainly, maybe I should write this down and decide over here. So I'm seeing that this is cosine squared x dx is equal to cosine x sine x. That's struggle, isn't it? Plus, well, I'm going to write the sine squared in terms of cosine squared. So it's going to be 1 minus cosine squared x dx. Same thing as sine squared. So I think I can, maybe write something else down here. And this would be cosine x sine x plus 1 dx minus the integration cosine squared x dx. And what's on this over here? Just this over here. By the way, someone says you're still left with the same thing. I am. I'm coming back to that cosine squared. But now what do I notice? This here can be added to this one over here. Now I could have done that before in the end, and it would just simply said 0 equals 0. That doesn't help me. But now what do I get? I get 2 cosine squared x dx is equal to cosine x sine x plus 1 dx. Now, by the way, this looks like it's doable now. So let's write this down. So what do you get? 2 cosine squared x dx is cosine x sine x plus some constant. All right. What am I going to do now? Divide both sides by 2. And what do you get? Cosine squared x dx is equal to cosine x sine x over 2 plus x over 2. And when you divide c by 2, you get another constant. I'm just going to call it d. You can continue to call it c if you want. I'm going to say that's my answer. I did the integration. Let's go back over here and see how we did. And I'm seeing it. I'm seeing it right over here. Okay. That was tough. I hit a dead end, and then I hit another dead end, and I kept going. Right. So I did it. I did what they asked me to do. Now what I want to do is I want to do their other recommendation, which is write cosine squared in terms of 2x. So let me write this over here. So the cosine of 2x, if you recall your Math 120 material, is 2 cosine squared x minus 1. All right. So cosine 2x plus 1 equals 2 cosine squared x. I'm taking their other suggestion, by the way. Over time, when you take hints or suggestions, you're going to get better at giving yourself suggestions. And this is not a bad suggestion to be given. So I'm going to write this down now. And what do they want to do? They want to integrate cosine squared x dx by using that substitution. Let's write it down. And what do you get? Cosine 2x plus 1 over 2 dx. Now, I realize some students are going to look at it and say, that's a more difficult problem. It's not. And I'll tell you why. I'm taking a square problem, and now I got it down as a linear. So let me write this over here. So it'll be 1/2 plus, you know what? I'm going to factor that out. Whoops, I didn't mean to do that. Let me just get my eraser out. I'm going to factor the half out. And I'm ready to integrate. No dead end here. What's the antiderivative of cosine? That would be sine of 2x over 2 plus x. Well, you know what? This may look different to you, but I want to point out that this and the other answer are identical. Let me go through that with you. So it's going to be 1/2. Let's write this over here. Sine of 2x is going to be 2 sine x cosine x. These are things you learned in Math 120. See some arbitrary constant over here. What would you get over there? Well, you'd get sine x over cosine x over 2 plus x over 2 plus some constant integration. Is that what we're expecting to get? Yeah, that's what we're expecting to get. We got the same answer over here. All right, same exact answer. All right. What was easier though? And that's a call that you need to make. But I got to be honest with you, making a substitution where a square becomes a linear term makes it easier for me to deal with the problem. So I think that this side was easier than the other one. The other one, I initially hit a dead end. I had to back out of the dead end and start again. And I had to start rethinking. I had to rethink. All right. Ooh, this one doesn't. Oh, this one has no hint. All right. So I got to write this one down. They want to verify it though, but there's no hint. So I'm going to write this one down over here. I'm going to try to verify. Someone's going to say, I have a better way of verifying. You could differentiate the right-hand side. But anyway, I don't want to do that. I want to do U substitution. I'm sorry, integration by parts. So U, I don't know, maybe X. Du is dx. Then this forces me to say e to the minus x dx is equal to dv. You know what? I want to put in the same order I'm always writing it down. So let me do that. Because sometimes I put things out in different order. It confuses people. So dv equals e to the minus x dx. That means v equals e to the minus x over minus 1 plus some kind of integration. But I'm going to do that in the end. Let's write this down. So what do you get over here? Minus x e to the minus x plus, the reason I'm saying plus, it's minus a minus, e to the minus x dx. Let me do that. Again, the integrations are becoming easier now. There's going to be at minus x, e to the minus x, and this is going to be minus e to the minus x plus c. Let's see if we did what it said to do. Did we verify what they want me to do? Well, minus x e to the minus x. Well, we did a good job. All right. Let's go to the next one. Again, they want me to verify this. And let me write this down. All right, I want to remind you of a couple of different things. And certainly, I'm hoping you remember that, how to differentiate the arc sine function. So I'm going to say u equals the arc sine. Now, someone says, oh, you're mixing notation over here. I just want to point out, some people like to run, sine to the -1, which means inverse sine. Other people like to write arc sine down. So what would du be then? Well, it would be 1 over 1 minus x squared dx. Now, granted, someone says, this is crazy. It's just going to make my life really difficult. I don't know that until I try it. And what am I going to do? I'd say, if I say u is equal to arc sine, I would have to say dv is equal to dx, which means v is equal to x. All right, let me do this over here. I'm going to see if I can do it. And this is going to be, let's see, x times the arc sine of x minus, well, let's see, that's going to be, let's see, v du, right? So that's going to be x. If this gets worse, it's not a good direction to take it. I'm done with this and cross it out. I'm not going to use that again. Now, by the way, when I say cross it out, I'm just done looking at that. Now what I want to do, and looking at that second integration, I wonder, is it easier? And it does look easier. I'm going to use u substitution now, not integration by parts, but u substitution. So I'm going to say u is equal to 1 minus x squared, and du would equal minus 2x dx, which means minus 1/2 of a du is equal to x dx. Let me see if I can do that. And again, I know it's difficult, but I want to write this down for you. So x over 1 minus x squared, the root of it, dx. If I were to use u substitution, a little star over here, just to remind me that I need to go backwards. And what would I get over here? Well, x dx is minus 1/2 of a du. And what do you get in the bottom? Well, you'd get u to the 1/2 power. Well, I think I can do that. I'll put down what I mean by that. U to the minus 1/2 du. How do I do that? Oh boy, that's going to be tough, right? So minus 1/2, not really, add 1 to the exponent. That would make it a half, right? And then divide by half, like multiplying by 2. I know there's a good constant integration over here. I'm not too worried about that. But I got to go back to the land of u's, and it's going to be minus the root of, right? What's u? Can't remember. Look back. It's 1 minus x squared. So I think I'm ready. I'll put it over here. What are you going to get over here? X arc sine of x. What did I get? Minus a minus, right? So plus the root of 1 minus x squared. All symbols integration have been removed. Put my c down over here. Now let's see if we've done what they said that I'm supposed to do. And did I get it? I got the first guy, second guy, got the c. Good job. All right, let's go next one. Oh boy, this is a problem now. And they say use u substitution to verify. And by the way, I would much prefer to use u substitution to verify this. So I'm gonna try to verify their work. And that's the whole point of study, by the way. You're actually verifying that what they say is true. So let's put this down. It's gonna be 0 to 1. And this is gonna be x cubed. And we're learning. And it says use U substitution to verify it. Oh boy, this might be tough, right? So let's take a look at that. And probably what I would do is, well, let's try U substitution. I'm going to say U is equal to 4 plus x squared. And then du, I'm not saying it's going to work, but I'm saying I'm willing to try it, is going to be 2x dx. That's not so bad, right? Let's put this down. So we're going to go directly to the land of u's now. So if x is 0, that's a lower limit, the u would be 4. Now, if x is 1, the u would be 5. And what do you get on bottom? I'll write it down for you. You would get u to the 1/2 power. I got troubles on top. What do I have? I have x cubed dx now. So what do I know about that? That's really just x squared times x dx. What's x dx? It's 1/2 of a du. All right, that's the x dx. What's x squared? It's u minus 4. All right, so I think I'm ready to move forward. And I know it's difficult, but I want to move forward. 1/2, 4 to 5. This should be u. I'm going to reduce this. U to the 1 over, that's u to the half, right? Minus 4 u to the minus 1/2 du. Let me keep moving. And I'm going to write this down now. Again, I realize for a lot of students, this is just so much work, they don't know where it's going to stop. It's going to stop when I verify it. And what do you get over there? Well, I have to add 1 to that exponent, which would be 3/2, and divide by 3/2, like multiplying by 2/3. Minus, well, I got to increase that exponent by 1, which would be 1/2, divide by half, like multiplying by 2, which would be 8. Limit integration 4 to 5. Mistakes happen. I want to encourage you, if you're making mistakes, try to clean them up. All right, let's write this down. So let's take a look at this. This would be u. I'm going to simplify this integrand, not integrand, but the antiderivative over here. So let's see, it's going to be u to the 3/2 over 3 minus 4 u to the 1/2, limit integration 4 to 5. I got to put this down now, all right? So upper limit's going to be 5 root 5 over 3 minus 4 root 5 minus the lower limit. Well, I get a 3. 4 to 3, that's going to be 4 times the square root of 4, which is 2, minus 4 times the square root of 4, which is 2. All right, I still have some work to do. And the kind of work I'm going to do is just, basic grade school arithmetic, common denominator of 3. So you get 5 root 5 minus 12 root 5s minus 8. And let's see, 3 times 8 is going to be 24, right? Oh boy, I don't know if I'm going to get this one right. Arithmetic, right? 3 minus 8 plus 24 is 16 minus, that would be 7 root 5s, right? Let's take a look. 16 minus 7 root 5s over 3. I did it. All right, I did it. So I use u substitution. Now they say use integration by parts. All right. Now, granted, the way some students do this may be different than others. The way I do it, you may not like the way I do it. You may want to see it done an alternative way. We're here to help you. All right, we really are. And certainly the only way to help yourself is by trying. So I'm going to write down the indefinite integral. And I'm going to take your suggestion. U equals x squared, and then dv well, this is easy, this part. This is 2x dx. All right. The other one's a little more challenging though, but honestly, for a lot of students, it's very challenging. So I'm going to erase it though, but I want to put down what I mean by this. I'm looking at this over here. I'm looking to get that antiderivative. So I'm going to put a half there and a 2 there. Now, why is that? I'd say this would be the u, and this would be the du then. All right, that's not so bad. So you get 1 over u to the half, u to the minus 1/2. So this would be 1/2. That would be u to the minus 1/2, u to the half, over half multiplied by 2. So it's just the root of u. Okay, I'm going to erase this. I want to point out that's a struggle for a lot of students. All right, let me just see if that's true. You get 1 over, yeah, it looks good. All right, let's write this down now. And I got troubles immediately. And let's put this down. Whoops, I don't mean to do that. I need to put UV down. Minus VDU. Now, you know what? I don't want to do that yet. All right, just an indefinite integral. I think I can do it now. All right, so let's write this down. X squared, 4 plus x squared, minus, let's see, if I did a u substitution, right? So I would do the same u substitution, 4 plus x squared, then it'd be 2x dx. So it would be u to the half. That'd be u to the 3 halves, right? U to the 3 halves. Divide by 3 halves, like 2/3. So it's going to be 2/3. And then the u is 4 plus x squared to the 3 over 2 plus c. Okay, let me get my little eraser out. I want to erase this business over here. So really, someone says, what? That's a lot of work. And what I'm really looking to do, I'll write down what I'm looking to do. I'm looking to evaluate. I'm sorry, I have to remember it's 0 to 1, right? 0 to 1, x root 4 plus x squared dx. Well, I know the antiderivative now, and it's going to be this. I'll write this down for you. It's x squared, 4 plus x squared minus 2/3, 4 plus x squared to the 3 over 2. This negation 0 to 1. Let's pop it in, see what we get. And what are you going to get over there? I got to really be careful about this. This would be, let's see, I would get 1 root 5, which is root 5. I'm doing the upper limit, minus, what would you get over there? 2/3. And I'm doing 1. That'll be 5 root 5. And now I'm going to do the lower limit, minus, well, it's going to get tough. 0 minus 2/3. And that'll be 4 to the 3 s, because if x is 0, you get 4. 4 to the 3 s is going to be 4 times 2. It seems like some work over here. So let's put this down. I see a 3 still, common denominator. That would be, let's see, 3 root 5s minus 10 root 5s. And this is going to be plus now, right? And that would be 16, because 2 times 4 times 2 is 16. And what do you get over there? 16 minus 7 root 5s over 3. By the way, I found the integration by parts far more difficult than u substitution, and that's generally true. Am I getting the same exact answer, though? Of course I am. All right. So let's keep moving. The next question. And let's do number 9. And number 9 says verify this one. And again, I'm looking at it and they're not telling me what to do. Try it. Let's see if we can get it. And what I'm trying to do is I'm trying to do 1 to 2, x cubed, natural log of x, dx. And I want to verify that that's number over there. So the way I'm going to do that is I'm just going to do the antiderivative of it, of the indefinite integral, and see if I can do that. This could be really tough, though. Let's write this down. I'm going to say u is natural log of x. And du would equal 1 over x dx. And then I would say, let's see what I would say now. I'd say dv is equal to x cubed dx. And that means v would equal x4 over 4. Let's see if that helps me at all. Put this over here. So this would equal, let's see, x4 over 4 ln x minus, let's see, the v, which would be x4 over 4 times the du, which would be 1 over x dx. Now, let's see if we can do it. x4 ln x over 4 minus, this would be x cubed over 4, right? So x cubed over 4, I have to increase it by 1, so it'll be x4 over 16 now, plus c. So that's a lot of work to do that, and mistakes do happen, but I didn't want to do that. I wanted to do this guy up here. So let's write the antiderivative down. What's going to be x4 ln x over 4 minus x4 over 16. Limit integration would be 1 to 2. All right. Again, it might seem crazy, but I got to do it. It's going to be work. So what's the upper limit? Let's see, a 2, right? So it's going to be 2 to the 4th power. 2 times 2 is 4, 8, 16. 16 by 4 is 4. So 4 natural log of 2 minus, let's see what that would give me. That would give me 16, right? 2 times 2 is 4, 8, 16 by was 1. Minus, let's do it a lower limit now. What do you get over there? Let's see. What's a natural log of 1? That would be 0, right? And then you get minus 1/16. All right. Let's see here what we got to do now. I guess I got to do the arithmetic, right? So you get 4 natural log of 2. Let's see, minus 1 plus 1/16. That's 4 natural log of 2. That would be minus 15/16. That's my answer. Now let's look at their answer. Oh, their answer looks different, doesn't it? Well, I got the minus 15/16, but they're saying it's a natural log of 16. Well, what I noticed about this over here is that this is really the natural log of 2 to the 4th power. This is what you learn in Math 119, which of course is that answer. So we did verify it. All right. 2 to the 4th is 16, by the way. Oh, we're done. What does that mean? You should be saying, when do I get a chance to try? Here, you try. Now, when I say you try them, see if you can do them. I'm still going to publish the me working at the whiteboard to do that, though, for those students that need additional support in watching someone do the problems. All right. Thank you for your attention. Again, if you need any assistance or help or you're confused, please come by and I'll try to help you.